We are starting with the concept of differentiation using the concept of first principle, a very basic concept. Let's look at this paragraph first. Let me underline the main details. The gradient of a curve is constantly changing. We know that. If it's not constantly changing, it would have been a straight line. We can use a tangent to find the gradient of a curve at any point on the curve. That is basic math. The tangent to the curve at a point A is a straight line that just touches the curve at A. So this is some basic knowledge. And then it says the gradient of a curve at a given point is defined as the gradient of tangent to the curve at that point. Why? Because if I look at this particular point and if I zoom in, and that's the maximum I can zoom, so this part of the curve behaves as a straight line. So that is the basic knowledge that we have. Now it says the tangent to the curve at 1, 0, this is the point 1, 0, has gradient 1. So the gradient of the curve at this point 1, 0 is equal to 1. The tangent just touches the curve at 1, 0. It does not cut the curve. So this is also important. It does not cut the curve, although it may cut the curve at other point. Now we have seen questions like this, in which past paper question, let's say this graph is going like this. This line is going like this. So it would be cutting the graph at some other point, but at this point, it's just touching the curve. So let's move to the next page. Now the question says, the diagram shows the curve with equation y is equals to x square. The tangent t to the curve at the point 1, 1 is shown. So this is the point 1, 1. Point A is joined to point P by the chord AP. So A is joined to P by the chord AP. Calculate the gradient of the tangent T. So if I calculate gradient of tangent T, I should choose the point 1, 1. I should choose the point 0.50. I have chosen these 2 points. And this line has a constant gradient. So the gradient comes out to be 2. Now it says calculate the gradient of the chord AP when P has this coordinate. Now we are coming to the principle of differentiation using first principle. What it says is that the closer I bring P to A, the better is the estimation. So P is 2, 4. That's right over here. This is 2 and this is 4. So P is over here. And then P moves downward 1.5, comma 2.25, then 1.1, comma 1.21, and then a little bit, just very close, 1.01, comma 1.0201. Now this thing was not in the syllabus. That's why I cancelled it out, omitted it out. Now when we calculate these 4 gradient between A and P1, this is coming out to be 3. Between A and P2, it's coming out to be 2.5. Between A and P3 is 2.1. Between A and P4 is 2.01. So look at the values of the gradient. 3, 2.5, 2.1, very close to 2.01, which is very close to the total. This is what the first principle says. Closer the point P is to A, better is the answer of gradient, better is the estimation of gradient, and that is the gradient of the tangent. Now, the same working from the book. The same concept again explained over here. As point B moves closer to the point A, the gradient of the chord AB gets closer to the gradient of the tangent to the curve. So that's the kind of question that they ask. This is the same kind of working, just ignore it. Let's look at this question. Now, this is from the P1 specimen paper 2020. The syllabus was changed in 2020. So this concept was introduced in 2020. Now, what does this thing says? It says the following points A, B, C, D, and E are given. Lie on the curve y is equals to fx. So let me just erase something from here. And let me just show you the working. Now it says the gradient between A and E, that is given. So this is A, this is E. Then the gradient between B and E is given. That is this one. So first is the blue one, then is the purple one. Then the gradient between C and E, that is this one. And the fourth one, the orange one, that is between D and E. So that is this one. What do you notice? E, the common point is E in all of them. So basically, this is just like this thing, that E is the common point, and A, B, C, D, the closer that you are to E, the better is the value of the tangent, the value of the gradient. So now this is, E is 2,9, this is 0, this is 1, this is 1.5, this is 1.9. So D is the closest one to this particular point. So let me mark it over here. So D is closest to E. So therefore, the best gradient is this thing. They made you calculate the gradient between C and E. So that is just basic calculation. They made you calculate the gradient between D and E. That is again basic calculation. Complete the table to show the gradient CE and DE, and state what values in the table indicate about the value of f prime of 2. So whatever is the curve, we don't know. F prime x means gradient of tangent. Since D is almost very, very close, just around the corner of E, if this is 2.1, we can say that the gradient of f prime 2 is almost equal to 2. And whatever is the function, if we would have applied the principle of differentiation, the gradient of tangent to the curve would come out to be 2. That is the concept of first principle, something very basic concept. The only new thing that you need to understand, the points are very, very close. The closest the point is to the given point, the better will be the gradient. Let me show you one other point. This is from May, June 2021, 1-2. Now it says the equation of a curve is this thing. The following points lie on the curve. Non-exact values are rounded to 4 decimal places. So let me erase this. And let me just erase this thing so you can have a good view of it. First of all, it's saying, find K, giving your answer correct to 4 decimal places. So now, if I plug in this value, and I write when x is equals to 2, so K is this value. This is by plugging into the Y particular value is K. That is basic maths. Find the gradient AE, giving your answer correct to 4 decimal places. So A has x coordinate 2, E has x coordinate 3. So we found the gradient of AE. So AE comes out to be 1.7321. Now look at the different values. So let me start underlining it. So this is A, and then this is B, and then this is C, and then this is D, and E is our standard. We are calculating the gradient with respect to E because it's asking the gradients rounded off to 4 decimal places are such and such. State a reason, giving your answer what the values of the 4 gradients suggest about the gradient of the curve at point E. So now this is 2, this is 2.9, this is 2.99, this is 2.999, and this is 3. So which gradient will be the closest? That would be the gradient of DE. So this is gradient of AE. Gradient of DE is coming out to be 1.997. So the gradient of the tangent is approximately equals to 2. We just round it off to the nearest integer value. So that is the concept of first principle, and this is the mark scheme. So that completes this concept. Let me close down the first recording.